So, first talking about the different congruency criteria. For triangles. And then there's also similarity criteria for triangles. Now, for congruency criteria, there were a total of 5 different congruency criteria that you had to know worked to say that triangles were congruent. Can somebody tell me one of the congruency criteria?
Side, side, side.
Side, side, side. Side, angle, side.
SSA?
SSA. No.
AA. No, it's not.
AAS did work.
This is exactly what the class.
Which, again, AAS you could also recite as SAA. Yeah, I'll just tap it on here. Thank you. That's not one of the criteria yet. We'll talk about that tomorrow with our proofs, but yeah.
What's the other one?
Kind of the opposite of that one.
ASS. I mean
ASA.
We barely use that one.
And then there's one more that we learned after the main 4. It did not use S's and A's. It used.
Wasn't it? Was it like
It was for HL. It was for a right triangle.
Oh yeah.
Hypotenuse leg. So again, this stands for side, 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 angle, side, angle, angle, side, or side, angle, 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 side, angle, and hypotenuse leg. Now, the difference between some of these, so like this one and this one, the difference between these, yes, there's 2 angles in both. Yes, there's one side. But again, the way it's written changes the meaning. This one, having the S between the 2 A's, means that we're talking about 2 angles and an included side. Whereas this one means we're talking about 2 angles and a non-included side. Right. Now, there is also similarity criteria for triangles. So, which ones would allow us to say similarity?
Oh.
Nope. Okay, so let me just mention CPCTC real quick, because back when we were doing our proofs, once you're able to prove triangles are congruent, then you're able to use CPCTC to say that all the other parts are congruent. But again, we're going to talk about that more tomorrow when we get back into our proofs. All right. So these were to say triangles were congruent, and again, in order for these to be true, again, all 3 sides had to be congruent, 2 sides and included angle had to be congruent, and so on. Similarity criteria. There were a couple that we had. Anybody remember any of the similarity criteria?
Similarity criteria?
Yeah.
Isn't SAS one of our triangles or congruent?
So, SAS,
I was right.
SSS.
SSS, drop 1A, AA. So, for similarity, these were the ones that worked for similarity. And because, again, you can have 2 sides and include angle, all 3 sides, or just 2 angles. But now the similarity was slightly different than when we had our congruency. Because in congruency, all these parts had to be congruent whenever you used them. For similarity, angles are still congruent, but sides are, what do you mean by similar? Proportional. The P word, yeah. So, again, the side, so like this would be, SSS would be all 3 sides are proportional with one another. This one, you have 2 proportional sides and the included angles congruent. This one, you just have 2 congruent angles. You don't have to do all 3 angles, because then you also have third angle theorem for triangles, which says if 2 angles are congruent, then the third angle must be congruent. So again, all you need is 2 angles in order to say that all 3 are actually congruent. Therefore, we only have to have 2 angles to show similarity. All right? And that's why we don't have to have either of these 2 listed because these already include two angles. So again, it's already covered by AA. All right. So those are the main congruency criteria. Now, there are other things that we did in this section. We talked about similarity. We also had set up proportions to solve things. So I'm going to go over a couple different types of problems. Some of them are going to be about the congruency criteria for triangles. Some are going to be about the similarity criteria. And then the rest of them are going to be about setting up proportions. So I'm not going to have us do any new notes on proportions. We're just going to look at some different problems. So first set of problems here. Zoom out. So, what is the correct congruency criteria for each one of these? So, take a minute, look them over. There's 4 different ones there. See if you can identify which congruency criteria would say that these triangles are congruent. So, hey, to yourself first. To yourself first.
Geometry, at least like we're saying,
You're just reading stuff and regurgitating. It could be both.
I love those.
Yeah, those two there isn't as much of a line. It's more regurgitating information.
I'm just like this.
Well, there are some application questions.
Yeah.
There are.
This thing should be.
5 seconds.
5 seconds.
Those are hard. You know how hard it is in section?
Hey, oh, one more thing, guys, because again, I've had to tell a couple people this because they brought to my attention that, hey, you know, I was working on the tests on Algebra Nation, and it was all algebra and not geometry. Again, like I pointed out in class, you have to make sure you go to the drop-down menu and select geometry so that you're doing geometry. So make sure you're doing the right one.
We can
You finish the test, you after I
actually
out of
just
that
sent
test.
you
Is that like systems of equations? Is that algebra? Bro, I've been taking algebra this whole time. You're so stupid. I did 4 sections on algebra. Bro, I'm doing tomorrow. They're due tomorrow, and I did all of them on algebra.
Alright, I'm here. Oh. That's up to you. Because, like, I would like, if you have questions on it, you know, work with how you see if it's wrong, but if you just want to look at it, that's fine.
What is that?
Sir, so we don't get the,
The geometry really.
the algebra is like system of equations that will take
Alright.
It's all that stuff. Like when you first log in and stuff.
Yeah,
for geometry.
if you're answering stuff from last year, and you have any questions from this year, you forgot to
Sir,
say
I was doing all of them. I did 4 sections.
Yeah, I did 2 sections.
It took me at least, I would say 6 hours to do all of them.
No, it did not. No, what? Oh, geometry?
You have to get a good grade for algebra. I did all that on algebra.
Well, again, you should know which class you're in. You're in geometry.
I thought the link you sent us was just like straight up.
It's the Math Nation. That's why in class I specifically went over it and pointed out. Alright. Okay, anyway. I don't know what this backwards doing. They're not feeling okay. You go into like a rave? What are you doing?
No wonder it was so hard.
Alright, anyway. On number 2. Here we go. What do we have here? SAS. But I only see 2 sides. I don't see an angle.
Congruent angles.
How? vertical. The vertical angles are also congruent. Again, they might not have everything labeled, but there might be other things that you're able to label based on what's given to you. So here, we're able to label that those two are going to be congruent, so you can use that. So we have side, angle, side. All right, on the next one. Angle, side, or side, angle, angle. Again, it's the same thing, no matter which way you put it. So, again, this side is being used in both triangles, so it's the same in both. On this one, angle, side, angle. Angle, side, angle. And the last one, side, side, side. Again, this one's in both. Any questions? All right, moving on. So, on here, now you have to put which one they correctly correspond to. Because when you write a congruency statement for triangles, it should tell you exactly how the parts are corresponding. So let's just go through this one together. What does angle N correspond to? N. What does angle A correspond to? O. M-O? N-A. O-C? P-A. Angle C? Angle P. And finally, NP is MC. Yeah. Good.
Why can't the geometry be like that? Why can't that just be the entire geometry?
Again, there's stuff from all throughout the year. Some of the stuff in the beginning of the year will be really easy. But again, it's been a while since we've done some of it, so that's why I wanted to go over some questions. Go back to like the first like 2 chapters.
Yeah, I don't mind.
All right. Given the triangles below, what is the possible congruency statement? Select all that apply. So, take a minute, look at them.
That one works. Yeah.
No.
But that second one works. Like 1, 2.
Oh, for real.
That one works.
The fourth one also works.
Can you do it, Mr. Susan?
I don't even know what you're trying to do.
Teach him. Oh, God. Try and do it. Wait, what? Am I doing it? Yeah, I'm doing it. Am I doing it right? How do you start?
Yeah, how do you start? What are your hands?
Not like this. No,
Like painful.
And then it goes like this. And then it goes
Like this? I don't know.
And then it goes like that.
I think that's all I do.
And then it goes back.
Hold on.
I quit.
Look, I'm gonna teach you.
I'm gonna try. I wanna know if my arm can do it.
What are you doing now?
I wanna know if my arm can do
That,
it.
right?
Yeah.
Okay.
Down, and then like go to the V. And then
How are you going into a V from there?
look. Down.
Oh, yeah.
What?
Is this?
Oh yeah, look, you have to V.
Something like that.
You're at the V.
Quite
And then,
what the heck?
and then you go like that.
I'm not going the right direction.
Oh, yeah. Hold on.
It's like you're like doing like it's kind of like that figure 8 thing that's like.
I think we have to
But I
after
can't
me.
quite.
Oh, yes, sir.
Anyway, moving on.
Or like whatever this is.
Which ones work?
Oh,
So those two. So you said this one
yeah.
and this one.
And then the other one.
What?
I didn't say the first one yet. I only did.
You think the fourth one as well?
Yes, I do. Yeah. Oh, wait, hold on.
Hold
I'm
on.
dyslexic.
This one?
I know. No.
It's just these two, right? All right. So now you guys, listen. Again, you can do this whichever way you want. Something that I do when I get a problem like this. Notice how you have some congruency marks there already to help you out. So see how there's 1 mark here, 2 marks here, 1 mark here, 2 marks here. Just to help me out, you can go and you can write things out like A is 2, N is 1. So 2, 1, 1, 2, 1, 2, 2, 1. And then same thing for B and K. I have B and K, 1 and 2, 1 and 2, 1 and 2, 1 and 2. Now, why would I do this? Because it helps me match them up a little bit easier. So, do I have the 1 and 2 in the same position here?
Yes.
Yes. Do I have them in the same position here?
No.
Do I have them in the same position here?
Yes.
Do I have them in the same position here? No. So again, those two work. Again, you don't have to use that strategy. It's just something I think is easy to visualize when doing a problem like this. All right. Okay. All right. Next. What missing information do you need to know in order to prove that the triangles below are congruent? Select all that apply. So right now, keep in mind, you currently have an angle and a side. All right? Over here, you also have an angle and a side. So, keep that in mind. Keep in mind what you have while you're trying to identify which ones work.
Miss Bezak, I think your hair's getting long.
There's things like
That's the back. Growth.
The back, yeah, not too much here. Very thin.
I was gonna teach you like that. You would say then like a week later, you would say nothing here, and like everything here. And it was just like, see that you think you can braid your hair?
Do it anyways.
Braid it.
You can braid your hair.
Go back to the pillar.
We're gonna give you a Vikings here.
You don't gotta be perfect. You just gotta be worth it.
Like every single one. Especially that one. Oh my god, karaoke.
Yeah, junior year you already
That's the whole week. We should just do karaoke. Oh yeah.
I keep shame off.
Oh no, you really
Oh,
should.
okay. What missing information?
You were looking at.
I don't own it.
No. Yeah, you're right.
Never works. Alright.
Whatever.
That's a TikTok move. They go like this.
Yeah.
And then they go like this.
One of them wrong.
One of them are.
I know.
That's why I got it.
Okay, well, you know, you freaking won't give the jacket.
Yeah, so that's good now. So, on here, those are the correct three. So, going through them real fast. If we had K and O would then give us ASA, right? They're in the same corresponding positions. J and N, that would give us angle, side in both cases. Angle, side, so that works. On this one, here, let me write that down so you know. So ASA, angle, side. This one, these two don't correspond. They're not in the same position. So that doesn't work at all. This one, we have JO and MN, that would give us SAS. And then again, these two aren't in. Oh, sorry. I said that wrong. Which one was not in corresponding positions? One of these wasn't corresponding. JK. Okay, sorry. These are in corresponding positions, except if you're using this, it'd use SSA, which if you spell that backwards is a bad word, and we know that one doesn't work. That is not one of our congruency criteria. So, and then those two don't correspond. Now, moving on. Ladies and gents. All right, on number one. If polygons are similar, then the corresponding sides are proportional. All right, sides are proportional. And then the second part, angles are. All right, so sides are proportional, angles are congruent.
Very well rounded.
I got a question. We don't have an exam in here, right? Because we have the EOC.
The EOC is your exam.
When's the EOC?
Next Thursday, Friday.
How long do we have to stay for each session?
Again, you guys will be in there for an hour and 20 minutes. Yeah, basically, you'll be in there through the end of 7th period. And then after that, you guys can go, or if you want to stay through 8th, you can stay through 8th. Okay, you have to be in there for 90 minutes. I will not be in this room. I will be in the media center with you. So there won't be a 7th period for you to go back to. So that's why this class specifically will be doing it for at least 120 minutes. I'm going to be in there through 7th period. So you guys can stay in there through 7th period. All right.
Yeast infection.
On here, the diagram below. Guys, I know you're wound up a little bit because of the biology EOC, but
Can we just have like 5 minutes to like?
no, just like turn your heads off. No.
No, just chill out.
You need
You're
to
key and
to
press.
understand.
All right. In the diagram below, angle triangle PQR is similar to triangle JKM. What is the measure of M? How do you know that?
Wait, no.
I don't think that's right.
No, that's not right.
So this should be equal to R based on this statement. So you got to find that one.
Minus 51 plus 8.
49. Okay. So angle M is 49 degrees. What is the scale factor of PQR to JKM? So again, they use the word 2 in this. The way they wrote this, we're doing this one over this one. So pick a side that you have in both triangles. The only side that we have in both is these two sides. So 18 over 6, which reduces down to 3 over 1, or just 3. Okay. What is the length? What is the length of PQ? So PQ we have to solve for. We're missing this side. I'm going to call it X for right now. It's matching up with the 5. So X and 5. And we had 18 and 6. Which again, if you already reduced it over here, so if you wanted to, you could have used that reduced version. Cross multiply. 15 equals X. And that's it. Alright? Good? Moving on. Well, we got lots more proportions on here. So, alright, let me zoom out just a little bit. So, answering 2 questions there. And in both questions, you have 2 parts. You're choosing one of the similarity criteria, and you're writing a similarity statement.
I don't like it.
So, alright, the first one is definitely side, side, side. So then, what's the correct order?
Correct order? Side by side. Wait.
L, M, K.
Yeah.
Alright, what about this one? Which one's correct?
That's side angle side.
Alright, and what's the correct matchup there?
BEF.
B, E, F?
Yeah.
Yeah. Good. Again, you have to make sure you go in that same corresponding order. More proportions. Had to solve for D and P. So this was P, and this was D.
Oh, proportions. Tim, you got to cross multiply, right?
You have to cross multiply.
You Yeah.
Yeah.
Okay, so okay.
Yeah. Yeah, as long as you get it to me sometime tomorrow, I'm fine.
Yeah.
Okay.
I know.
So on here. Now, doesn't matter which one you want to solve for first, right? You can solve for either one. Give me a proportion we can set up. And remember, you have to solve for one of the variables at a time. You can't do both variables in the same proportion. So you have to solve for one at a time. Give me something that works.
15 over 12, and it's 10 over whatever that was.
10 over D?
Yeah.
All right, that works. That is the correct way to set up that proportion. That's right. Probably right before you got down to the office, they had called for it. Yeah. So, again, we have, guys, again, this is the correct way to set up the proportion using these four numbers. Again, any proportion we write, there are four different ways that you could set it up. So, just as another example, 10 over 15 could equal D over 12. Again, both of these are correct ways of setting it up. Because notice, when we go to cross multiply, we're multiplying the same numbers with each other, right? So 15D equals 10 times 12.
120.
So 15D equals 120. Divide by 15.
Wait, didn't you say there was something about 5? Does it work with 15?
Yeah, it doesn't really work well with 15. For this one, there's so many ways that you can do a problem. All right.
Wait, was I right with that 112 though?
So on here, for example, again, if you're using a calculator, great. The answer, you should get it pretty quick. But say you weren't using a calculator, I would go with 30 for a second. Right? 15 goes into 30 how many times?
2.
Twice. How many times does 30 go into this? 4. So 4 times 2 is? 8. And that's our answer. Again, you can use smaller numbers to help work that out, right? So, again, if you wanted to do 120 divided by 15, plug into the calculator, that would probably be on the calculator part of the test, I would think. But that's D. Now, there's lots of ways to set up the next proportion. We also had to solve for P. We could use the 8 that we just had here. So now we know this is 8. And we could do P over 10 equals 4 over 8. That would work. Or we could on P over 15 equals 4 over 12. That would also work. So using those two sections. So there's like 8 different proportions we could set up here and still get a correct answer. Now, it doesn't matter which one you do, you get the same values. So here I could reduce, that's 1/2. Cross multiply, that's 10 equals 2P. Divide by 2, and P is 5. If I had done this one, it's the same thing. This reduces as well. 1 and 3. 1 times 15 is 15. That's 3P. Divide by 3, and you get 5. So again, as long as you're setting up a correct proportion, you should get the same answer no matter what. All right? So again, P is 5. Alright, so again, it's a proportion that you have to do here. Try to solve for x.
That's pretty disgusting.
I don't know how.
Whoa.
Yeah. Dude, I wish I was
Wait, I love you forgot it.
It's not
There's only 2 before you can only do one of them. You can't. Hold on. Wait, how do you do that again? You use it's like.
I would do this over this equals that over that.
Okay.
Cross multiply and solve.
Hold on.
But again, anytime you set a proportion, there's really 4 correct ways to set it up. So.
Hold on.
Bro.
9 times.
Bro. Bro, what's
I was doing one about like the.
The music is ripping.
Wait, hold on, man. Hold on. Hold on. Wait, what? Hold on.
Take it out. It looks so stupid.
Whoa, I can't
Well, my man, you're right. Mrs. Bezak, is X a whole number?
I thought it was. Let's do it. So, again, different ways to set it up. This is just what I would have saw when I first looked at it.
That's what I did too.
Which then again, you can cross multiply and solve. Now, you can choose to do this a couple different ways. But again, so I have 9 times 3x plus 2 and 12 times 4x minus 2. Now, you could go ahead and multiply right now. But I see the two numbers that I'm multiplying by are values that have similar factors, right? 9 and 12, they both have what in common? So to make this a little bit easier, instead of multiplying by that big of a number, there's nothing wrong with saying, hey, let's just go ahead and divide both sides by 3 and reduce this. So I'm dealing with smaller numbers. All right. So now I get 9x plus 6 equals 16x minus 8. Subtract off the 9x, you're left with 7x. Add the 8 over to this side, you get 14. Divide by 7, and you get 2. Now, again, is there anything wrong with using the bigger numbers and actually multiplying out 9 and 12? No. All right. And if you set up a proportion a different way, maybe you had it set up as 9 over 12 equals 4x minus 2 over 3x plus 2. Well, then 9 over 12 would have been a fraction all by itself, and it would have reduced there. So again, more than one way to solve this. All right. Let's keep going. I'll take it. So, Malik runs on a trail in the park. He normally runs one complete lap around the trail, A, B, C, D. So, he's running on this track. The length of each side of the trail is shown in meters in the diagram below. If this is a similar shape to trail A, B, C, D, what is the minimum distance in the nearest whole meter Malik would have to run to complete one lap around this figure? So now, a couple of things to keep in mind. We can identify a scale factor here, right? Let's first identify the scale factor. So we're going from this one to this one, right? So which side matches up with the 100?
90.
Why the 90?
Because it just looks like it does.
Why?
Because it's more slanted.
Okay. Well, down here it says specifically the order, right? So this is our similarity statement. It's written down in words, but that's still our similarity statement. So that's telling us how they match up. So we got these two match up. So I got the 100 over 90, which reduces to 10 over 9. That's our scale factor. Now, we don't have to find every side. Remember, scale factor also works for perimeter. So if I do the perimeter of the small one first, then there'll be less work than finding every single side. So add this all up. This plus this is 190. This is another 92. So That'd be 282. So now we have a perimeter. 10 over 9 equals x over 282. Cross multiply and solve. Oops. To the nearest whole meter. So again, a little bit tricky because if he ran 313 meters, would he have completed a lap? So again, on this one, you gotta be careful because the wording is tricky. You'd have to increase this no matter what the number. It's not just normal rounding. So this one's going to go up to 314. Because again, if it's 313, he didn't complete a lap. So again, you gotta be careful on rounding that before. Huh? Just one. What do you mean? How many meters? 313.3, which we're going to have to round up because we round down and we want to have completed a lap. It's like it's similar to a problem where, like, if you're doing something based on perimeter and you're enclosing a space, well, you need to make sure you round it up to enclose the space. Like, say you're buying something by a foot, you couldn't buy not enough or it won't be enclosed. All right, on here. When we have an angle bisector, the sides are proportional to the side that's being split. So this piece down here is 14 minus t. So 12 over 16 equals t over 14 minus t. And you'd have to solve that. So I know I didn't give you guys a chance to try this one on your own, but again, the property for this one is when we have an angle bisector, the sides of the angle that are being bisected is proportional to the side that's being bisected, the two parts of the side that's being bisected. So these two sides are proportional to those two pieces. So you can reduce this, cross multiply and solve. Where t equals 42 minus 3t. You get 7t equals 42. Divided by 7, and t is 6. Yeah, I had two more, but I don't think we're getting there. We only got 3 minutes. Let's do this one. This one's faster. Let's do this one. All right. Complete the similarity statement for the right triangle. Remember, when we have a right triangle and an altitude drawn into the right angle, it's split into 3 similar triangles. I showed you guys the method where, like, if you use dots, you can put dots in the corners. It's like smallest, medium, biggest, smallest, medium, biggest. So you can use the pattern. Here, RST, 2, 3, 1. So use that pattern for the rest of it. Huh? R, 2. S is this entire angle here, 3. And T is 1. Yeah, this was for the big triangle. So now, the other 2 smaller triangles, same pattern. 2, 3, 1, SPT. And for this one, 2, 3, 1, RPS. All right. Ooh. Bell hasn't rung yet. These two are our properties with our geometric means. Altitude equals geometric mean of part 1 times part 2. Leg, geometric mean of adjacent part and the whole. Alright, we're done.
My brother always.
Don't worry, Mrs.